This video is based off of Chapter 2, Section 1.
We are using iMovie and Notability.
We can organize data in a frequency distribution. A frequency distribution is the organization of raw data in a table form, using classes and frequencies. There are several different types. Frequency is the number of times something occurs. So in this example, we look at the raw data to create the chart, which looks like this. There are three types of frequency distributions. The first type of frequency distribution is a categorical frequency distribution, which is used for ordinal sets of data. So blood types, for example. In this example, we used the 4 different blood types as the classes. For each of the blood types listed in the raw data, you can cross them out and make a tally next to the class to help you keep track of how many you have of each. All the tallies added up next to each class is the frequency. Add up all the class frequencies together, and in this case, they added to 25. And there are 25 different blood types listed in the raw data. To find the percents, just take each individual frequency and divide that by the sum or total number of frequencies. All the frequencies added up should add to a total close to 100.
A grouped frequency distribution is used for large sets of numerical data. Each class is an interval range. There are certain steps that make a grouped frequency distribution. First, determine the class's limits and boundaries. Boundaries. To find the lower boundary, you're going to take the lower limit and subtract 0.5. For example, if the lower limit is 30, you're going to subtract 0.5 and you're going to get 30.5 as the lower boundary. For the upper boundary, you're going to add 0.5. For example, if the upper limit is 37, you're going to add 0.5 and you're going to get 37.5, which ends up being your upper boundary. Or if it's in the tenths, you're going to do the same thing, except you're going to add and subtract 0.05. For example, if the lower limit is 7.8 and the upper limit is 8.5, you're going to subtract 0.05 and add 0.05. You're going to subtract 0.05 to the lower, and you're going to add 0.05 to the upper. 2. Make class widths odd, so that way there is a midpoint. The midpoint formula is the lower boundary plus the upper boundary all over 2, or the lower limit and the upper limit all over 2. For example, if the lower boundary is 24 and the upper boundary is 30, you would add 24 and 30 and divide it by 2, which would equal 27, which would be your midpoint. Or you could do the lower limit and the upper limit, which would be 23.5, and the upper limit would be 30.5. You add them and you divide it by 2 and you also get 27. If it's odd, there's always a guaranteed midpoint. 3. Between 5 and 20 classes, they'll usually give you the amount of classes. 4. Classes do not overlap, so you won't see the same number in another class. 5. Classes must be equal in width, so if it's 5 to 10, it's going to be 10 to 15. You must have all of these to be grouped in it, to be a grouped distribution. So here we have ungrouped frequency distributions, which are used for smaller sets of data. So instead of the class limit being 35 to 41, 42 to 48, etc., it's going to end up being the one number in the data. So here we have an example of an ungrouped frequency distribution. Data shown here represents the number of miles per gallon that 30 selected four-wheel drive sports utility vehicles obtained in city driving. Construct a frequency distribution and analyze the distribution. So first you're going to determine the classes, and the range of data is small, so they can just consist of single data values, which is 12, 13, 14, 15, 16, 17, 18, and 19. If the data is continuous, class boundaries can be used, so you subtract 0.5 or add 0.5 to the upper boundary, subtract 0.5 from the lower boundary. Next, you're going to tally the data, and lastly, you're going to find the numerical frequencies from the tally and find the cumulative frequencies.